Have you ever wondered what makes Earth so uniquely suited to life? Is it the water, the air, or perhaps the energy from the sun? When astronomers search for planets beyond our solar system called exoplanets, the ultimate goal is often to find ones that might support life. But what does it take for a planet to be habitable? In this video, we're diving deep into the key characteristics that make a planet capable of sustaining life, using principles from astronomy and planetary science to guide us. To start, the most fundamental requirement for life as we know it is liquid water. Life on Earth is intrinsically tied to water, and it's often referred to as the universal solvent because it helps chemical reactions necessary for life to occur. For a planet to have liquid water, it must reside within the habitable zone of its star, sometimes called the Goldilocks zone. This is the region where temperatures are just right, not too hot and not too cold for water to exist in liquid form. Planets too close to their star, like Venus, face extreme heat that evaporates water, while those too far, like Mars, experience frigid conditions that freeze it solid. But water alone isn't enough. A planet also needs an atmosphere to regulate temperature and protect life from harmful radiation. Earth's atmosphere is a delicate balance, composed of nitrogen, oxygen, carbon dioxide, and trace gases. It not only provides the oxygen we breathe but also acts as a shield, blocking harmful ultraviolet UV radiation and stabilizing temperatures. Without an atmosphere, a planet would face extreme temperature fluctuations, as seen on the Moon or Mercury, where the absence of an atmosphere causes scorching days and freezing nights. Next, a planet needs an energy source to drive biological processes. For Earth, this energy primarily comes from the sun. Sunlight fuels photosynthesis, the process by which plants convert light into chemical energy, forming the base of the food chain. However, some forms of life on Earth, such as those near deep-sea hydrothermal vents, rely on chemical energy instead of sunlight. This expands our understanding of habitability, suggesting that a planet doesn't necessarily need to orbit a star to support life. It might just need an internal heat source, such as geothermal energy from its core. Another critical factor is the planet's size and composition. A planet needs sufficient mass to maintain an atmosphere. Smaller planets, like Mars, have weak gravity, making it difficult to hold onto atmospheric gases over time. Additionally, a planet's internal structure plays a role. Earth's molten core generates a magnetic field, known as the magnetosphere, which protects the planet from solar wind, a stream of charged particles emitted by the sun. Without this protective barrier, the solar wind can strip away a planet's atmosphere, as it did with Mars billions of years ago. The planet's orbital stability and location in the galaxy are also important. A stable orbit ensures consistent conditions that allow life to thrive. If a planet's orbit is too eccentric, it could experience extreme seasonal changes that challenge the survival of life. Furthermore, the planet's location within the galaxy matters. Earth resides in the galactic habitable zone, a relatively calm region of the Milky Way that's far from destructive forces like supernova explosions or the intense radiation of the galactic core. Beyond these basic requirements, scientists are also investigating the role of chemical elements. Life on Earth relies on a few key elements, often summarized by the acronym TOPS: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Carbon, in particular, is a versatile element that forms the backbone of organic molecules. When searching for habitable planets, astronomers often look for chemical signs of these elements, especially in a planet's atmosphere, as potential indicators of life. One intriguing consideration is the potential role of moons in supporting life. Earth's moon plays a vital role in stabilizing our planet's axial tilt, which affects climate stability. Without it, Earth's tilt could vary wildly, leading to dramatic climate shifts that could make life more difficult to sustain. Additionally, some moons in our solar system, like Jupiter's Europa or Saturn's Enceladus, are considered potential candidates for life due to their subsurface oceans, despite being far outside the sun's habitable zone. As we expand our search for habitable worlds, it's important to remember that life might not look the same everywhere. While Earth-based life depends on water and carbon, alternative forms of life could rely on different solvents or chemistries. For example, Saturn's moon Titan has lakes of liquid methane and ethane, raising the possibility of entirely different biochemistries. This challenges us to think beyond Earth-like conditions and broaden our understanding of what makes a planet habitable. In conclusion, the quest to identify planets capable of supporting life is a fascinating blend of astronomy, biology, and planetary science. From the presence of liquid water to the protection of an atmosphere and the energy to fuel biological processes, there are many factors that play a role in making a planet habitable. As we continue to explore exoplanets with tools like the James Webb Space Telescope and upcoming missions, we get closer to answering one of humanity's biggest questions: are we alone in the universe? If you enjoyed this deep dive into the conditions for life on other planets, don't forget to like, subscribe, and share this video with fellow space enthusiasts. Let's keep exploring the cosmos together.